Welcome back. In the last session we have seen how we have solved this problem using ANSYS. Now we're going to see that how ANSYS solve in background this kind of problem. So ANSYS basically uses this plate as a CST element, and it solves a CST element elemental stress equations. Now what is the CST element is? The CST element is a constant strain triangle element. Now why it is known as a constant strain triangle? Because if you'll see this element, it's a linear 2D element. Linear means only corner nodes are there are no mid-side nodes. So there will be a linear variation of its primary variable. Primary variables means we are finding out deformations. Now based on deformation we find out another variables, so that is known as a secondary variable. So in secondary variable will be based on deformation, we'll find out strain, after that we'll find out stress. So the stress and strain are secondary variable. We'll first in FEA will solve and we'll get the primary variable, that is U. Now this primary variable variation across throughout the element is linear, so that its dependent variable, that is a secondary variable, or its derivatives such as a strain and stress are constant. So therefore, as a strain is constant throughout the element, it is known as a constant strain triangle element. Right, so just let me open the ANSYS and show you what I'm telling you. That the strains are constant throughout the thickness, right? It's having single value here, x, y, or any values. So therefore this is known as a constant strain triangle element. So how ANSYS solves this problem is using this equation. Stress is equal to D matrix into B matrix into U matrix, where D matrix is a material property matrix, right? So it's based on which kind of theory we are using, which kind of 2D case we are using, either plane stress or plane strain or axisymmetry kind of cases we are using. So based on that, D matrix is determined. So if you remember, we have this D matrix for our case, right? And here we don't have this is the D matrix for our case. Now next is the stress is equal to D matrix into B matrix into U matrix, so that is a strain. Now what is this B matrix? It gives the relation between strain and displacement. This B matrix is based on CST constant shape functions. Okay, so we are not going in detail about how this B matrix is. If you are interested in looking how this B matrix is derived for the CST element, we have added the PDF below so that you can see and download. So it basically solves this equation. Stress is equal to D matrix into strain, and where the strain can be found out by B matrix, which is a strain displacement relationship matrix, into displacement variable. So based on this we can find out the stresses, right? So we have solved this using how FEA does. We solved this and we have observed that we got the same answer what we got in ANSYS. So if we'll take that, so stress will be equals to, right, stress will be equals to D matrix, B matrix into U matrix. D matrix is given by this plane stress approach, and we get this matrix B matrix, which is a strain displacement matrix, right? It's given by this 1 by 2a, beta 1 0, beta 2 0, beta 3 0, 0 gamma 1 0, gamma 2 0, gamma 3, and gamma 1 beta 1, gamma 2 beta 2, gamma 3 beta 3. Now this beta 1, beta 2, beta 3 and gamma values are given by this. So these things, I think so you have already studied in the matrix, how to find out this using matrix. The area of a triangle is given by 1 by 2 into this. If we'll take 1 by 2 here, so 2 times of area is equal to determinant of the coordinates and this, right? So from taking determinant of this matrix, we get the area. And if we'll put here, and beta and gamma values are given like this. There's a simple way to remember this. You might have studied in a matrix how to find out this positions, right? So we get the B matrix, which is a strain displacement matrix like this. Then if we multiply D matrix and B matrix, we'll get this, and we'll take this here, we'll multiply with u1 v1 u2 v2. This all 4 values are 0. There is only display because this is a fixed end. u3 and v3 values are given, so we are going to give it. So here there is a typo, it's not 11.14, it's 1.114. If we'll solve this, we'll get the stress value in x direction is 1.5 megapascal, right? This is a megapascal. Sigma y will be 0.4485, there is a 0.45, and tau xy is 3 megapascal. So let's check this with the answers also. So if we'll go to the answers, there sigma x is 1.5, which is also matching with our hand calculation approach. Sigma y is 0.4485, that is 0.45. Tau xy is 0.3. There is a typo mistake here because that value is got an error, so it's 0.3 actually here. Right, so if we take this all the things, we have seen that it matches with the it matches with the hand calculation approach. So that's all. We have seen a 1D problem, we have seen a 2D problem, how it can be solved using ANSYS. Now next session is on heat transfer problems. We will see on a structural mechanics problem, rod element, truss element, 2D element, beam element. Now we are going to see the thermal problem, thermal analysis.